quadratics are all about this thing, x raised to the power 2. It's all about this one thing and the expressions that you can make from this one thing. So something that would perhaps be like x squared plus 4, or maybe even just x squared, or maybe x squared plus 2x plus 1, or maybe even x squared plus 3 by 4x. All of these are quadratic expressions. And what makes an expression a quadratic expression is, of course, this thing right over here, this x squared. Now, all expressions that have x squared cannot be quadratics. So, for example, this thing right over here would not be considered a quadratic expression. And the reason is because the x term with the highest power is not x squared, but in fact is x cubed. And so this thing right here is not a quadratic. All of these are quadratics because they have an x squared, and they do not have anything higher than an x squared. So if any of these equations had x cubed or x to the power 4, x to the power 5, so on, then they would not be considered quadratic equations. And these equations generally, if I show you that these equations, they're basically following a really specific form, and we call it the standard form of a quadratic equation. So if I show you what the standard form looks like, it basically looks like a x squared plus bx plus c. And I can show you guys that in fact all of these things, they follow the standard form. And let's look at the first one. So we have x squared plus 4 over here. So how would we even get that from this standard form? Well, if your a was 1, this thing would be 1x squared. If your b was 0, then you would get 0x. If your c was 4, then you would just put 4 in place of c, and so this thing would basically simplify and become x squared plus 4. Okay. In the same way, I can go ahead and show you guys what this thing looks like. And so if you have 1 as your a, then this thing would be 1x squared. If you have 0 as your b, you would have 0x. And if you had 0 as your c, this would be 0. And so this thing would basically just simplify to x squared. So you can see all of these expressions that I wrote, they follow the standard form. You can go ahead and try out this thing right over here and this thing right over here. But they basically follow this standard form. This is the standard form of the quadratic equation. And of course, there are two more forms that that these quadratics can take. They can take up two new forms. So this is form 1. Actually, call it form 2. We call this form 3 because the standard form would be the first form. And we'll see how we can get this form using 1 and this form using 2 or using 1. You can basically go from 1 to 2, from 2 to 1, from 1 to 3, right? You can change forms. It's not a big deal. But right now, this thing right over here is what the standard form of a quadratic expression looks like. And this thing right over here is what makes a quadratic expression quadratic. Now, this is going on, of course, this is what's going on with the algebra. There's a graphical side to this. Of course, you've seen the equation y equals mx plus c. That's the algebraic equation. You know, on a graph, it makes a straight line, something like this. So in the same way, this thing right over here, ax squared plus bx plus c, is what makes a quadratic expression. But on a graph, this thing actually makes a smiley face or a sad face. So you can get any of these two faces. It depends on what this thing is. These values, the values for A, for B, for C, basically tell you what your smiley face or your sad face is going to look like. And we'll see how that works. But for now, the main idea over here is that algebraically, this is what a quadratic looks like. And graphically, the smiley faces or a sad face is what a quadratic expression looks like. And remember, quadratic expressions, the heart of quadratic expressions is the x squared. So of course, if you have ax squared plus bx plus c, b and c can be any number, so can a, but a cannot be equal to 0. And the reason for that is because let's say I make my a equal to 0, I make my b equal to 1, and I make my c equal to 3 over 5. This thing would basically turn out into 0x squared plus 1x plus 3 over 5. And so this term would basically just disappear, right? This x squared would just disappear, and I'd be left with x plus 3 by 5. Now this thing doesn't have an x squared, so obviously it's not going to be a quadratic anymore.